In this video, we're going to look at how to graph the hyperbolic trigonometric functions. And in particular, we're going to graph sinh, cosh, and tanch. So these are the hyperbolic sine, cosine, and tangent. So the method that we're going to use to graph these is, we're just going to use a little bit of inspection first. So we'll draw our coordinate axes. So here's our coordinate axes. And let's start by drawing sinh of x. So we're going to draw y equals sinh of x. So I'm going to actually write it down here because I need that room. So y equals sinh x. So let's look at y equals sinh x. So remember from the previous videos, we defined it as it was e to the x minus e to the negative x over 2, and that was the definition of sinh. So what happens when we plug in the point 0 is x? You get 1 minus 1 over 2. So it's going to be 0. So 0, 0. Then if you plug in big values as you get bigger and bigger x, this e to the x becomes very large, but this e to the negative x becomes very small. So you're just going to get bigger and bigger values. So it's going to become something like, it's going to go up like this. Now, if you get very small values, then it's going to be opposite. This e to the x is going to become very small, and this e to the negative x can become very large. But this negative sign will remain, meaning that it's going to become very large negative values. So it's going to go like this. And it does look like that. So it might resemble x cubed, and if you just looked at it, you might think that's x cubed. But in reality, that's not x cubed. X cubed comes like this. So this black graph is y equals x to the power of 3. So that's just a comparison for you. So that's how sinh looks. Now, on the same graph, I'm going to draw cosh. So now we're going to say y equals cosh x. And remember, instead of negative, it's positive here. So let's think about how that's going to act. When you put 0, this becomes 1 plus 1 over 2, which is just 1. So it starts up here at 1. And then if we put in bigger and bigger values this way, then same idea. This becomes very large. So this just goes up with this. And then if you put in negative values, then they basically just switch signs. So, but it's going to remain plus. So it's going to go up like this. And as a reference, a parabola starts down at 0, 0, and it actually exceeds. It starts looking like this, but then it exceeds. So it goes outside. It goes at a faster. But let's forget the parabola and the x cubed for a second, and just look at the two graphs that we're interested in, which is cosh and sinh. So let's draw those again really fast. So it looks like this, and then cosh x I'm going to draw. Cosh x looks like that, and sinh x looks like this. And they do go together after a while. They start going together, and they go upwards in that direction. And the reason is because their derivatives equal out. And by that I mean, remember the derivative of cosh x is sinh x, and the derivative of sinh x is cosh x. And if we write their equations, they're going to be e to the x plus or minus e to the negative x over 2. That's the equation of both of them. And as you get bigger and bigger numbers, this e to the negative x becomes negligible. We can just ignore it. So both of their derivatives are essentially e to the x over 2 after they get very, very, very large. So that's how they act. Now let's do a quick exploration of tanh x. Tanh x is interesting because it has an asymptote. So let's just look at, tanh x is defined as sinh x over cosh x. So if we divide, it's going to be e to the x minus e to the negative x over e to the x plus e to the negative x. So that looks like a mess right now, but we can clean it up a little bit. So what we're going to do is we're going to first split this up. So it's going to be e to the x over e to the x plus e to the negative x. And we're going to add it to, actually we're going to subtract e to the negative x over e to the x plus e to the negative x. So it's looking a little bit more manageable now. And then we're going to take each of these to the power of negative 1, which allows us to flip the insides. So it's going to be e to the x plus e to the negative x over e to the negative x. And this is going to become e to the x plus e to the negative x over e to the x. And that's good because now we can reduce further. So if we split e to the x and e to the negative x up, this becomes e to the 2x, and that becomes 1. So it's going to become e to the 2x plus 1. And this becomes e to the negative 2x plus 1. So e to the negative 2x plus 1. Okay? And then I'm going to erase our initial little statement up here. And I'm going to write this as I have it up here. So it's going to become 1 over e to the negative 2x plus 1 minus 1 over e to the 2x plus 1. and then I'm going to get rid of our bottom statement down here. Now, what's the limit? I'm going to take the limit as x approaches infinity in this case. So since it's subtraction, we can treat each part separately. So this first part right here, this 1 over e to the negative 2x plus 1, as you approach infinity, this number gets negligible, and this just approaches 1. So this approaches 1. And then this, as it approaches infinity, we're going to get that as this approaches infinity, this number becomes very, very, very large, and the 1 doesn't even matter, and 1 over a very large number is 0. So it's 1 minus 0. So in total, it approaches 1. And that's true. And if we did negative infinity, it would approach negative 1. So we're going to see that the graph of tanh x looks a little something like this. So here's the number 1, here's negative 1, and it comes like so. And it will, I drew this a little bad, it should approach the asymptotes. So if we draw our lines, then it'll approach it like that. And that is our y equals tanh x. So hopefully that gives you a little bit of insight into the hyperbolic trigonometric functions graphs. And until next time.